Good morning, everyone. My name is Vaibhavi Dattatreya Godare, and I am here to be present all firmware of Advanced Driver Assistance System. So, here are the all codes related to the ADAS. Here is the ultrasonic sensor code and in core source the main program of the ultrasonic sensor. Here is the total code I wrote. All headers and functions are defined here, and also all clock files and STM32 files are also here done. Then after that I have done with timer code also. Here I completed the total timer code. Here is the main C code of timer. Here timer handle type def is also defined and static function is also defined. Along with that, include file is also here. Here is the include file of timer. This is the code of one ultrasonic sensor using one ultrasonic sensor, and here is the code of using three ultrasonic sensors. We can see that here is the code which contains three ultrasonic sensors. We use three ultrasonic sensors because we have to take the distance from left side, right side and front from front. So that's why we use the three ultrasonic sensors. Here is the total code of three ultrasonic sensor. We can see that in while function, here is the D1 is equal to ultrasonic read. This is the one ultrasonic sensor, and second is the D2. It is the another ultrasonic sensor, and D3 is the third ultrasonic sensor. So like that we use the three ultrasonic sensor for taking the distance from three sides, front, left and right. And in debugs we can find binary files, mapping files like that. Also IOC is there. In IOC we have configuration pinouts. It takes some time to open. We can see here is the IOC of three ultrasonic sensor. Here is the pinout configuration. PA0, PA1, it is GPIO input output of one ultrasonic sensor. Then PA2, PA3 is the GPIO input output of second ultrasonic sensor. Like that PA4, PA5 is the GPIO of third ultrasonic sensor, and PA9 and PA10 are the UART receiver transmitter. They are used for communication between the ultrasonic sensors and the UART. And finally here is the EV dashboard, EV dash pinout configuration, EV control pinout configuration. and here also code of the EV control. So in EV control all the codes are here like ADAS. Here is the ADAS code which contains all the configurations like a speed, then speed from the front side, left sides, and also here is the speed is defined. Then after that all conditions which we have to check like collision will be done, collision warning is also here defined. Like that all conditions are defined in the ADAS. Then after that ADC is also here. ADC code is here. We use the ADC because of we need to convert the analog values into the digital values like speed, accelerometer, temperature. Because of that we use the ADC. Then fault manager is also there. Then here is the main code of ADAS. Now let me run it, then we can see that what happened. I run the code which is successfully run. Here is the 0 errors and 0 warnings. So these all related to the firmware of ADAS system. Now let's move forward to the hardware connections. For hardware connections, I use the PicsimLab simulator. Without using the actual hardware, I implemented the hardware connections on PicsimLab. Here is the total hardware connections of ADAS system. I use the 4 potentiometers for acceleration pedal, brake pedal, SOC and motor temperature. And here are the 3 ultrasonic sensors for left side distance, front side distance and right side distance. And here LED are used for give the warning lights, collision is done or we have to move from the road and we have to take a break for that, or like that. Likewise green LED is glow when there is no obstacles, and when red LED is glow, then we can assume that there is some issue or obstacles in our road. So here is the total complete hardware connections of ADAS system. We can see that here is the output is shown. SOC is 100, torque is 0, a range is 333. All these values are shown. Here is the front side, left side and right side distance TTT. Alarm is also here. Now let me show you Python dashboard. So for Python dashboard, I have to use CMD for commands. System internship. So, oh, here is the mistake. Embedded system internship. embedded system internship. Why system can't find? I don't know what happened. Now let me check once again. Yeah, my path is wrong. Download. Where is my file? Downloads, then embedded system internship folder. Downloads embedded system internship folder. Then now dashboard will be open after this command. Now dashboard will be open. Yeah, here is the dashboard will be open, which contains all the things we are implemented on the PicsimLab, and which we are um, wrote in the code in the STM32 cube ID. All these things are shown here. So here is the speed, then here is the alarm, but it show the status of alarm is known. Then bird eye view is there, like that in green circle bird eye view is here. In that bird eye view TTC is shown, and here is the EV matrix, which contains torque, acceleration, brake, then motor temperature, alarm, fault. All these things are shown here. This is the Python dashboard, which is connected to the VSP tool. So for that UART communication is used through the connectivity between them. So here is the total project will complete. Thank you.